no longer lonely or blue, for I have been kissed by an angel, beautiful, wonderful you.
Welcome back to the channel. So this is the second video in the restoration of this Philips Norelco B5X98A. In the first video, I discussed what an output transformer is and the fact that this radio doesn't have one. In this video, I'm going to go through some of the particulars of the restoration, and at about 13.5 minutes, we'll talk about the absence of the output transformer, how Norelco, how Philips achieved that, what the schematic looks like, and how it compares to most other radios that do have output transformers. Okay, so let's talk about the restoration. It all started with a renewed sense of the goodness in humanity. I found this on Facebook Marketplace, and I asked if I could come and see it. The person who owned it and was selling it said that she had to go to work, but she would leave it on her front steps covered in a towel if I liked it. Just put money in the envelope and leave it under the mat on the steps. So that's exactly what I did. So I knew I was in for a different type of restoration. First of all, it was made in Holland and not Germany. And the next thing, you can see the external speaker, the little graphic for the external speaker. It says 800 ohms. Well, that's different. Cosmetically, it appeared to be in pretty decent shape. The cabinet itself, the finish was still viable, just needed to be polished up. The bottom of the radio shows you these two red tabs, and I wasn't sure what they were. As it turns out, the chassis has 4 points that it screws onto, but the chassis has these big grommets and is not stable with just the 4 chassis screws, so it needed these 2 extra screws to keep it stable. So here is the tube layout. It's got some interesting tubes in it, an EL86 and an EF85. Both were relatively new to me. So here she is out of the cabinet on my desk, very dirty. And the next thing I do after taking the tubes out is putting the radio in a radio holder. This makes it safe for the radio, and it makes it easy to get to any part of the radio that I need to work on. It is sometimes a pain to make, but once it's done, it helps you out in the long run as you work on the radio. So here is what I think is the most important part of a restoration, and it could actually be the most rewarding. So this radio wasn't working. I needed to find out why. The schematics here actually give you a little chart in the lower left-hand corner that's called resistance readings, and it takes you through every tube pin connection, and it lets you know what the resistance should be. I followed that, but I also marked the circuits. The green circuits are the circuits that had resistance that was in spec, and the red lines are circuits that there was either no reading or the resistance was way off. And as it turns out, this radio needed a whole bunch of resistors, half-watt resistors, changed. They were burnt out. I replaced them with 1-watt resistors. As far as the capacitors went, I did replace all of the electrolytic capacitors. And to my surprise, there were not um, any significant paper capacitors. Now, I always like to think that the schematics are perfect. The radio needs to follow the schematics. Well, the schematics here drove me a little crazy because the pins of the ECC85, the FM tube, appeared to be switched. That's in the upper left-hand corner. There's a blue and a yellow tracing. As it turns out, the schematics were wrong. There were two resistors, I think it was R4 and R8, that were switched in the schematic. I checked this out by looking at a similar model, and of course when I was finished the FM section worked, so the schematic was wrong. So there were some caps that were suspect, the two in the picture there. They're both aerofoil 2, ERO foil FOIL number 2 caps. And in my experience with other radios, they have remained quite good over the years. So I took out my trusted capacitor checker and checked these two, took one lead off, and they were good. So this is my little capacitor tester. It was given to me from a friend who attends amateur radio hamfests, and I'm surprised at how well it works. I have other meters, but the one thing I like about this meter, besides giving you the capacitance, it gives you the ESR, but also it gives you a thing called percent V loss or percent voltage loss. And as I understand it, the little device puts in a voltage and then gives a specific amount of time, very short, and measures that voltage, and it'll tell you how much voltage was lost. And so it's not a leakage tester. I don't have a good high voltage leakage tester yet, but I'm working on it. I did replace the capacitor that showed the V loss of 0.4%. I can't tell you anything else about this meter, but that's the underside with the chip number. As far as the main filter capacitor, I found the best way to replace the two capacitors was by restuffing the can. I found this method to be the easiest. It works well. I cut the can in half, and then I can replace, I could put two new capacitors inside the can and then put the can back together, and it doesn't look all that bad. So here was the most difficult part of this restoration. It seems that they built this radio to take heavy bass, and in fact Transformerless radio is supposed to have better bass. And instead of putting the glass faceplate on with some clamps with rubber backing, the faceplate is held on by these two thick grommets that go into the faceplate and get pushed into the chassis. So I had a choice. I could try taking the glass off, knowing that the grommets were 60-something years old, very stiff, and breaking the glass, or I could sacrifice the grommet, get the glass off in one piece, and then make a new grommet. So I decided to sacrifice the grommet, and I did get the glass off in one piece, but then I had a problem. I had to make a new grommet. So it was off to Fusion 360 with the help of my son because this project was a little bit beyond my capabilities. Here is the old grommet that I cut off. And here is the new grommet that we eventually made and got it to fit. It was a project. The little feet on the bottom go into the chassis and fit snugly into the chassis. And when it was done, this is what it looked like plugged into the chassis. And luckily I was able to get the glass on it and put everything back together. Fusion 360 and the 3D printer came in handy. It needed 4 new legs, and it also needed some capacitor holders in the chassis. I was also surprised that this radio didn't have a fuse. It had what they call the metal link. I think that's what you see in the bottom left-hand corner that goes across the wiring. But just to be safe, I across the hot lead coming in, I used a polarized plug. I put in a 750 milliamp slow blow fuse that has been working quite well. Before putting it back together, I checked the amperage. It's drawing 0.586, 0.587, and the B plus was indeed 320 volts on my Simpson meter. I didn't do an alignment because I've heard so much about the Philips inductors, how they can break. The radio sounds pretty good at this point. We'll see what happens in the future. I am going to put in a Bluetooth module, and there's a link to the best channel for learning radio restoration that I've found. Electronics Old and New, and he shares his DIY projects. You can see these are 2 boxes for his Bluetooth module that goes inside the cabinet. The one on the left is the through-hole module box, and the one on the right is the SMD box. Well, the big white box does not fit in the cabinet, so it looks like I'm going to be putting together an SMD Bluetooth module at some point so I can install it inside the cabinet. So that's it for the restoration. Let me go on to discuss the audio amplification part of this radio, the fact that it does not have an audio output transformer. Okay, Philips output transformerless system. They described it as a single-ended push-pull system, which I think is confusing, or a single-ended output, which I think is better. It was patented by Harry Olson of RCA in 1947, but it was Philips that put it in mass production from 1955 to 1960. So what are the advantages of a system like this? What were they trying to achieve? Well, without a transformer, you can't have transformer core saturation, which is a problem with transformers. Supposedly you get a better bass response, and I think this radio was built for bass with all its big grommets and bushings. Extended high frequency response, lower distortion, less weight, and potential savings from not having a heavy output transformer. But they did have problems to solve. First of all, matching the impedance. They had to match the tubes with the speaker. Eventually, they cut down the impedance of the tubes system, but they had to make special speakers that were 800 ohm speakers with very fine wire. And number 2, they had to isolate the DC voltage, isolate the speaker from the 125 volt DC voltage, and they did that with a capacitor. And lastly, they had to increase the current from the tubes to the speaker. And of course they did that by developing the EL86 and putting it in series, as you'll see, with the EL84. Okay, let's take a look at the output section of a Grundig radio from 1955 using a single output tube and a transformer, an EL84 and an output transformer. So here we have the schematic from a 1955 Grundig, and this is a simple audio amplification section. It has one EL84. The audio signal comes into the control grid here. This tube is biased with a resistor. The audio signal is amplified, goes out through the plate, and goes into the output transformer. So you have a high impedance, low current signal being then changed in the output transformer to a low impedance, high current for this 4 ohm speaker to work. Okay, now let's look at a bigger radio with a more powerful output amplification section. This is a Telefunken Opus 7. It uses 2 output tubes, so it's 2 EL84 tubes and an EC92. All right, here is a Telefunken. This is a big radio. It's an Opus 7. And the audio section uses 2 EL84 tubes. There's one here and one here. And this is a push-pull amplification system. Basically, each EL84 is putting out a signal and amplifying the audio signal coming into the grid of each one. It puts the signal into opposite ends of the primary. You would think then that the signal and the magnetic field would cancel, but it doesn't, because one of these EL84s has had the audio signal inverted, and the EC92 does the inversion of the audio signal for one tube. So this uses 2 EL84s, and it is a push-pull amplification system in a big Opus 7 telephone. Okay, let's finally look at the Philips system, the output Transformerless system, and see if we can understand how they put these 2 tubes together, the EL84 and the EL86, to achieve the goal of getting rid of the output transformer. Okay, so now this is the audio section of the Norelco. It doesn't have an output transformer, as we know, and it uses an EL84, this tube here, which we've seen in the other examples, but it added an EL86 to solve the impedance and current problem. So I think the best way to understand this is, let's follow the DC voltage, and after that we'll follow the AC audio voltage, which is the signal. So DC voltage, you have the B plus, which is pretty high, 320 volts, which goes into the plate. The screen grid is also getting 260 volts. So the DC voltage goes into the EL86, and the voltage that comes out of the cathode, again, DC, is 125 volts. It goes through a resistor, and now the voltage at the control grid of the EL86 is 110 volts. So the tube is thus biased. The control grid is more negative than the cathode. And the voltage then goes to the EL84. Now notice the plate of the EL84, which typically gets its DC voltage from the B+, now is getting it through the EL86. And then it eventually goes to ground with a resistor, so this tube is also biased. The control grid is negative compared to the cathode. Okay, so that's the DC voltage, which is interesting how they did this. Now let's look at the audio signal. So the audio signal comes in here, comes into the control grid. The EL84 does what it normally does. It amplifies that audio signal. The audio signal then goes out the plate, and it goes into the control grid of the EL86. So this is a special tube. That control grid is now getting 110 volts DC, but it is also getting the amplified AC signal from the EL86. Now, instead of taking the audio AC signal from the plate, what it does is the cathode here follows the control grid. So it's a cathode follower, and the audio signal now comes from the cathode to the speaker. How do we protect the speaker from getting DC voltage? In the other examples, it was the transformer that stopped the DC voltage, but here it's a hefty 8 microfarad 450 volt capacitor that is stopping any DC from going into the speaker. It just lets the audio signal through. So this is the way they solved the impedance problem, because this system has a lower output impedance. It also has increased current, which the other systems could not produce. The problem is they couldn't get the output impedance down to 4 to 8 ohms. So they had to now match the speaker. The output impedance is about 800 ohms. So now Philips built speakers that had impedance of about 800 ohms. So they needed a special speaker and a special tube and a special setup. Okay, so you might ask, why didn't this system catch on? And why did other companies not use it? Well, they thought they would save money, but in the end they needed 2 tubes, expensive speakers, and a higher power supply. The other thing is that the hi-fi industry came about, and people were buying hi-fi equipment and different speakers because they were separate. So if you bought a Philips hi-fi system, you were told that you absolutely had to buy Philips speakers. And then lastly, transistors finally came into being in the early 60s. So I hope you enjoyed this video. Thanks for coming back for part 2. You can see part 1 if you missed it. It talks about the output transformer. and I hope to see you again. Thank you for watching. Enjoy a little bit of music from the external Bluetooth module that this radio has now. Hopefully soon it'll have an internal Bluetooth module. Thanks again.
Now who could have thought this could happen? Who would have ever believed? Could it be true that someone like you could fall for somebody like me? Now I'll swing along, happy as ever, no longer lonely or blue, for I have been kissed by an angel. Beautiful, wonderful, marvelous, lovable, beautiful, wonderful you.